Good afternoon, folks. My name is Bart Martindale. I'm guest host today. Welcome to today's broadcast of Stay Curious, brought to you by the American Space Museum. And it's also part of our Oral Histories series made possible by a grant from Marie Louise G Endowment. Now, I want to give a long introduction today for the very first time that I've ever been this long-winded in my introductions, because this man is a special, multifaceted gentleman. My guest today is a man named Steve Agid. He is a former space worker as a career. As a current career, he's a communicator in the same office that I'm in at Kennedy Space Center. He is, in addition to all of those space-related things, he's a historian, he's a presenter, he is a history preserver, and I'm most happy to say he's my friend. So we're going to talk about his career. We're going to talk about after his career. We're going to talk about a lot of stuff today. I want everybody to be ready to have your head explode, because that's what happens when you talk to Steve Agid. Okay? Steve, thank you for being here, my friend.
Thank you for asking me to be here, Bart.
Okay. Let's get started by just telling us what your background, your educational background that got you ready to do the things you're doing today.
Well, I came to Florida Tech in 1969. It was pretty much known as FIT back then. And you talk about perfect timing. Apollo 11 just landed on the moon in July, and I'm starting in September. I got a degree in space sciences and graduated from Florida Tech in 1974. And space sciences was a little bit of all the different degrees. We had a little bit of mechanical engineering, a little bit of electrical engineering, a little bit of biomedical engineering, and of course, heavy stress on the space sciences. And everything from orbit dynamics, which is what I ended up going into for my first job. So it was a very good, well-rounded career, a lot of the technical different fields.
Okay, now, we have followers that are on Facebook, that are on YouTube, and that are on Twitch. And looking at those various groups of people, would you have any recommendations or any suggestions about how they could go into what you went into those many years ago?
Well, there's lots of things. In fact, I'll be doing a broadcast, or I should say a meeting at the Florida Institute of Technology just next week, where I'll be talking about just those things. Everything from how to successfully conduct a job interview, what people look for, what do you need to do to prepare for a good job interview, things you need to do to stand out. And that's one of the things, for example, if we just have a minute here, one of the things I recommend to people is, if at all possible, if you get an internship, that is your best way to get involved in the industry for two reasons. Number one, the people that hire you have an idea of what you look like, what you're like for the period of X amount of weeks, not a one-shot interview deal. So they're used to working with you. And number two, just as important, if you work for a company for a couple of weeks as an intern, you might say that, well, engineering isn't exactly what I thought it was. Maybe I ought to switch careers. So it works out for both sides. But there's lots of other things you can do. And again, I can go into those, perhaps come back and talk a little bit more about that in a future show. Because I know that a lot of people have a lot of questions, and a lot of times, a lot of the students really don't know what it is the employer's looking for, and it's not just that A 4.0 average.
Well, as one of the communicators at Kennedy Space Center, when I began my job there about 3 years ago, the way I learned more than any other way was sitting in our office and listening to you and some of the other communicators talk about your past, your history, your experiences, your stories. So I want to take your career, because it's been interesting to me, and I know it'll be interesting to the folks that are watching this, and take it in the various parts. And I'm going to do something else that I've never done. I'm going to read, because this is too much stuff for me to have memorized. So, first part, 1976 to 1988, you worked for RCA and GE as a spacecraft controller and spacecraft orbital analyst for the fleet of 7 SATCOM communication satellites. Okay, you guys ready? Tell us about that.
Okay, what is that? Well, for the young viewers, it is not going to be easy to relate. Well, when we were growing up, unfortunately, Bart and I remember a lot of the same presidents. Most of the people around the country had 3 or 4 television stations. Well, when we started using what we call domestic communications satellites to broadcast throughout the United States, the TV industry exploded. The first companies to do that were Home Box Office and Showtime. You'd have to pay to watch television. Boy, was that a controversial subject. But we launched a fleet of satellites. There were two big competing companies at the time, Westar, which was owned by Western Union, and RCA Satcom, which was an RCA company which later became GE. The job was to transmit all that NASA data, plus, in addition to the NASA data, television programs, Showtime, for example, CNN, all the different cable stations, and now there are hundreds of stations that are available. Well, those satellites have to be in orbit. They have to be able to be controlled. When they're in synchronous orbit around the Earth, they do vary their positions. My job was to track the satellite, see where it was, fire the engines to move it back to where it needed to be, keep track of the satellites, make sure they're in good health. One day, for an example, the first time we broadcast the Super Bowl by satellite, the thought was, wow, if something goes wrong, people are going to notice, so that's the type of thing. One of the things that we got at the very beginning of this, again, we came online pretty much in 1976. Well, at the end of July 20th of 76, Viking 1 landed on Mars, first American spacecraft to land on Mars. We broadcast that by our satellite. So I got to see those first pictures of Mars right there as a spacecraft controller there at RCA. So that was a great moment.
So you got to literally drive the spacecraft.
There's a way of looking at it, yeah. And to control it from the ground, send commands to it, tell it what to do, diagnose problems when you can't go there and open it up.
Well, I'm going to interrupt a second.
Sure.
People don't think about this very often. You had to do the controlling from millions of miles away.
Well, in our case, 22,000 and change of miles away, yeah.
Well, I'm
over
talking
the equator.
About the Mars, well.
Oh, for Mars. Yeah, what happens is the Viking spacecraft sends a signal back to the NASA Deep Space Tracking Center. We have the ones in Goldstone, California, for example. When they get the data, they send it to our satellite. Our satellite sends it to all the different ground stations around the United States and eventually, to the world.
What kind of time delay is there?
Well, the time delay from Mars will vary depending on how far away Mars is, usually about 10, 20 minutes or so. Could be longer. Every mission is of course, different. Once the tracking station, and whether it's the one in Australia, the one in Spain, the one in Goldstone, California, once they get the data, they immediately transmit it to our satellite, which transmitted it to all the stations around the United States. So we weren't involved with the Mars except after we got the data. The same thing, for example, when we had the shuttle drop test. First drop test of the Space Shuttle Enterprise. Mm-hmm. NASA communicates it, we send it and distribute it throughout the United States. So that was our job, transmit all the NASA data network.
And then I watched it.
And then you watched it on TV. There you go.
Okay. Anything else you'd like to mention about that first phase of your career?
No, that pretty much summarizes what I did, and I did that for about 12 years.
All right. Now, 1988 to 2002, this is when you were involved in the manned space program. You joined the Payload Projects Directorate at McDonnell Douglas at Kennedy Space Center, worked as a task leader on 60 space shuttle missions. That's a lot, including 5 of the 6 Hubble Space Telescope flights, all 9 space station Mir missions, the Galileo Jupiter probe, the Magellan Venus probe, Chandra and the Gamma Ray Observatory, and several International Space Station flights. Your duties including writing the you showed me some of that. It's very complicated. The support procedures, payload processing and checkout, and integrated testing and inspections. Again, everybody needs to be ready to have their head explode. Go ahead. Tell us about that.
Okay.
Now, you have pictures of this, right?
I would have, and very shortly we'll be getting to them.
Okay.
So the way the program was designed, the way it worked down here, our job in the Payload Projects Office is they sign an agreement to launch a certain spacecraft. Well, we'll use Hubble as an example. So Hubble is going to be built. It's going to be sent down here. But the time from it's down here to the time that it's up there, it has to be checked out. They have to get it all the way here, shipped from the Goddard Space Flight Center. Once it arrives, you want to make sure it works as well as it can. So we have to do a lot of testing. So let's take a look at what we began in our testing. And this is a Space Shuttle Mission 31. Now, Hubble was launched on the 24th of April of 1990. So it's been in space for 31 years.
All right, now what's that picture on the left that we're
Okay,
looking at?
on the left, what you're looking at is the Hubble Space Telescope arriving at our test facility called the Vertical Processing Facility, or the VPF. Now, it looks like a very tall structure. It doesn't look like much. It looks like a big mechanical set of arms and such. It doesn't look like the space shuttle. However, it acts like the space shuttle electrically. We'll move it into this test stand. Once it's in that test stand, we'll connect it up. We'll use the same kind of cables that it will be used on the space shuttle itself. The idea is what we're hoping to do with this facility. As soon as the spacecraft arrives, no matter what spacecraft it is, the company itself that puts together the spacecraft does what they call a health check. Did it ship okay? Is there something that fell off? Did it look like it's working? Okay, it's working as good as we can get it to work. Let's move it into this facility to see if it could work with this make-believe shuttle, a shuttle simulator, if you will. We will put it through every test in this facility that it will eventually have to undergo when we load it into the real shuttle. If there's a problem, we'll find it here. They think it works right. We flip the switch, and it's not working. What's wrong? Did the shuttle do something wrong? Did the customer misunderstand something? Work all those problems. When that's done, when that troubleshooting is done, we'll move it out, go out to the pad, load it into the shuttle, and do the exact same test. There should be no problems.
Now you're talking about the initial Hubble mission.
This is the initial Hubble mission, correct?
Okay, and as we know, after that launch and it went into orbit, didn't work right.
Right.
So
how come we didn't catch that?
that's exactly what
Okay, I
was
knew you were
ask.
going to ask that because that was not our job. Okay, what the problem was the way, and I have a presentation on that. When the mirror was tested, okay, they did an initial test. When they did the final testing, there was a thought that we should actually test this out in a certain way. That test was rejected because of the cost. Well, there was a grounding error with the mirror. How much was it? And people think that there was this terrible out of shape part of the mirror. The mirror was off, not by much, by 1/40th of the diameter of a human hair. So that's how much it was off. Well, that test wasn't performed at the customer facility. We never tested it here, so that went into space. Once it got into space, they looked at what they did and found the mistake. People think on the STS-61 mission, which was the fix mission, which I also was able to work, one of my career highlights, people think we took out the old mirror and put in a new mirror. Couldn't do something like that. That mirror is almost 8 feet across. What we did is something that your optometrist would do for you. We can't fix the mirror. Think of the mirror as Hubble's eyes. We can't fix the eyes. What we can do is fix the way the eyes see. So we came up with a device called Costar, the Corrective Optics Space Telescope Axial Replacement. What it is was a set of little mirrors that were ground exactly backwards to what Hubble's was. So the light will come in from the universe into Hubble's mirror, reflect like it's supposed to, but right before it goes to the instrument that's recording that data, we have the equivalent of a contact lens, which will rebend that light so when it actually gets to the instrument, it's seeing it the way it needs to see it. So we never fixed the mirror. We did give Hubble
Corrective
contact
lens.
lenses, yeah.
So, okay, that gentleman on the right, that wouldn't be you, would it?
That would be me in a Hubble suit. Now, if you take a look at that Hubble suit, my wife was talking about the current situation we have here with wearing masks, and boy, that's going to be a lot of a problem. If you can see that suit that I'm wearing, I am buttoned up all the way from the bottom of my shoes. The only part of me that's exposed is my glasses. The idea is you didn't want any kind of material to come in contact with Hubble. And so there are 2 layers of gloves on. You can see everything is taped on. It took a while just to get dressed and then spend hours inside these clean rooms as we were doing some of the testing. We couldn't even use normal paper. We have special paper that wouldn't shred. So the paper you're reading my introduction off, we couldn't bring that into the high bay. We had special materials we had in that paper to make sure.
Wow.
So it's that sensitive. So dressing for Hubble, even that was an issue.
Wow. Okay, I'm going to move on to something that people don't talk about a lot, and that's mirror.
Okay.
That's an interesting subject to me, and let's talk a little bit about your involvement with the mirror.
Okay, so what we'll have to do is we'll go to the 3rd slide where we have the Mir space station. One more to go. There we go. When we worked with the Russians, there was a decision made to get the International Space Station. We were not going to be making an American space station anymore. There'd be an international space station. Part of that was to work with the Russians. And you got to remember, the year that we're doing this is 1995. The Berlin Wall fell in 1989, 6 years before. You had those folks on that side of the Atlantic, and us on this side of the Atlantic. I don't trust you, you don't trust me. And now we're working together. Not only working together in space, I want the viewers to think about this. In space, every breath you take is on borrowed time. There's nothing natural about space. A system failure anywhere, you're absolutely dependent on the next guy. So we're going to be, from being a perfectly good American space program dependent on our coworkers, to having to trust those other guys over there that we've never worked with before. Well, they came over here, and we had this vehicle you see in front of you right now, this big orange thing called the Mir docking module. What was its job? Well, the Mir is the Russian word for peace. It's the name of their space station. To get familiar with flying in space and operating in space for long periods of time, up till then, our longest period of time was the Skylab program.
Right.
Our longest flight, the last Skylab flight, 84 days. These guys are, Dr. Polyakov, over a year in space. These guys are really used to long flights. We're not. So the idea is, part of this getting ready for the International Space Station, get to learn to work with those Russians. We got this docking module meant. What its job was is connect one end to this Mir space station. The other end would connect to our space shuttle. The space shuttle will bring this up, connect to the Mir station, then disconnect at the end of the shuttle mission, leave the astronaut on board, and the next mission will make the docking a little bit easier. But here we are testing. Now we're going to be testing this Russian vehicle. That was a lot of fun because the way the Russians do testing and the way we did testing were very different things. We look for certain things, they look for certain things. If you look to the right side of the photo there, you see that little arrow, that red arrow, that's me in the middle of this test. Now, one of the things you might not think about is as we're doing the test, this is a Russian module with Russian Cyrillic characters, and our procedures are, of course, written in English. Well, we had translators. And as we're doing the testing took longer because I said do this and it had to be translated. So knowing that I was going to be doing what they call a task leader, which is directing a few people locally to do a job, I looked back to the Apollo-Soyuz mission, thought, how did they do things back then? And I found out that those crew members invented their own language. And I asked, what is the Russian word for make a connection? And it's a really huge word. And I said, well, what's the Russian word for married? And they said, zhnat. I said, oh, that's a nice simple word. So instead of giving this big, long Russian term to connect a cable, I'd say that and that, zhnat, 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 ne, zhnat. Ne is no or not. So we were able to go through this very, very quickly, me speaking very bad Russian, but enough to make the test go. Problem occurred during one of our tests when the folks in the Launch Control Center were listening to it. And one of the guys said, why are we hearing about this guy's marital problems? It had nothing to do with it. It had to do with whether these cables should be connected or not. Simple language. And I got that from the Apollo-Soyuz mission. So never try to reinvent the wheel.
And you had mentioned to me once before about the difference in translating and interpreting.
Right.
Because a direct translation can have a whole lot of different meanings than it's supposed to.
Yeah, we were talking about that just briefly before. One of the things you want to ask for, if you're ever in a situation where they ask you want an interpreter or you want a translator, most people say a translator. Well, a translator will translate exactly what you said exactly. An interpreter would say, okay, you said that, which means this. A great example of that is one of our very big meetings. We had one of our NASA counterparts talking about when we were going to do a certain test. He looked to the Russians and said, well, that's just up in the air right now. Now, most of us would understand, well, that's up in the air means we haven't decided yet. Well, it was translated as it's up in the air, and the Russians exploded that we're not going to do that test till it's up in the air. No, and that was really, so you don't, you want an interpreter that knows enough expressions to know that, okay, he said this, what he meant to say, or what he meant to say for you to understand is this.
I'm sorry. Do we have a picture of Mir itself?
Yes, we do. Next one down. So that orange test, if you look at the right side of this photo, there's the docking module actually connected to the Mir space station. That STS-74 crew, when they left, took that picture. Now, to the left part of the picture is me standing in the payload bay, right next to the payload bay, I should say, at the pad, loaded with that Mir docking module loaded on board. One of our jobs was to do a walk down. Right before we close the doors, everybody takes a look around the space shuttle itself and says, okay, everything is good. When they close the doors, the next people to see whatever we're taking into space, whether it's the Hubble telescope or the Mir docking module, the only other people that will ever see that will be the astronauts on orbit. So it's your last chance to look and see what it is. Okay?
All right. Now, I mentioned a couple of the other missions, the shuttle missions, excuse me, with the various probes, Galileo, Magellan. Which of the ones that you worked on was the most memorable, and do you think the most important, probably?
Well, the Galileo mission, everyone has a different memory for me. Galileo was important. It was the first time I was on console for launch, so I remember that vividly. And I remember we had the strangest launch delay ever. It was October, early October. We were going to launch, got close to the launch, and one of the tracking stations had an earthquake. So we stopped the launch due to the earthquake. So that's kind of unusual. Gamma Ray Observatory, first time I was a lead for McDonnell Douglas on that console. But I'm going to have to say, if you talk about missions, there's two. One we'll talk about at the very end of the program. And I'm going to have to say working on the Hubble Repair. I mean, Hubble was expensive. It's in space. It's a showpiece, and it's not working. Being able to work, being a part of that mission, and that, I mean, we were getting threats from the DC area saying, you know, if you guys can't fix Hubble, what makes you think you can build a space station when that's way more complicated than fixing Hubble? So this has to work. So working on that mission, and the fact that, you know, some missions are launched and nobody knows about it. Everybody knew that Hubble needed to be fixed.
What about, you know, that brings to my mind how worried we can be or not be about James Webb, the new space telescope.
Well, the James Webb is supposed to be going up in mid-November. The difference between Hubble and Webb is this, and this is very critical. The difference between James Webb and Hubble. Hubble is about 300 miles above your head, and it was meant to be operated on by the space shuttle. We have something called a grapple fixture on Hubble. You grab it, you can put it in the payload bay, the doors open, we can put new boxes in. We knew in advance that this is going to be up there for a decade or more. Right now, it's 30 years. We know electronics are going to get better. We know our instruments are going to be better. Can we plug out an old box and put in a new box? Hubble was meant for that to happen. So the equipment we have on Hubble now, way better than the equipment we had when we launched. James Webb is different. James Webb Space Telescope is going to be 100 times more powerful than Hubble. So that's going to be amazing. It is parked 4 times further away than the moon. It'll be 1 million miles from Earth. Something goes wrong, we can't get to it. In order to launch James Webb, it has to be folded up, which means it has to be unfolded. There are 189 pieces or we call latching mechanisms, that have to open up and deploy and get into their right positions in order for James Webb to work. If one of them doesn't work, James Webb isn't going to work, and we're not going to be able to go out there and hit it on the side or fix it or tweak it. So if it works, it works. I know the folks in Redondo Beach at Northrop Grumman have put it through a whole nother series of tests. They're sending it out to be launched. It'll be launched on an Ariane rocket, and that'll just be about another month and a half from now. It'll take about a month to get out to 1,000,000 miles, and if everything works, it's going to be 100 times more powerful than Hubble. So that's unbelievable.
All right. Now, we're going to move on to the next phase of your career. I want to take this opportunity to remind folks, this is Stay Curious. I'm Bart Martindale. This is Steve Agid. And these are American Space Museum Oral Histories, which is made possible by a grant from Marie Louise G. West Endowment. Now, from 2002 to 2016, you joined with ULA, and you were in the Delta rocket program, serving as an engineer, a task leader, and so forth. Now, I have been with you a couple times over to the Atlas and the Delta Launch Control Centers, and that's been an experience for me. I would like to just brag a little bit and tell people that one of the times we were in the Delta Launch Control Center, you made the statement, "That was my chair." And, you know, it's sort of like, that was my parking space. I mean, yeah. I didn't sit in the chair, though. Anyway, tell us about working there and some of the highlights of those years that you spent there.
Well, you said I came over in 2002, which was true, but it was not to ULA. McDonnell Douglas is who hired me here. McDonnell Douglas was absorbed by the Boeing company, and when I went over to Delta, it was still Boeing. The government wanted to make what we called assured access to space. They wanted to have one way to make a phone call and get our rockets launched. They wanted the two big competitors, the Atlas company, which was Lockheed Martin, and Delta, which was the Boeing company, to merge together. So they formed a new company, those rocket development parts, called United Launch Alliance. That's how ULA came to be born. That's early in 2007. So what did we do over there? And the idea is that we were sending our vehicles to send very large spacecraft into space. Some of those spacecraft, for a lot of the different companies, the Atlas spacecraft, in fact, we have an Atlas on the pad getting ready for a launch called the Lucy mission. That'll be sending us spacecraft out for the Trojan asteroids. Those are asteroids out in the orbit of the planet Jupiter. That's coming up just about a week or so away from that right now. Launching a lot of military satellites, a lot of communication satellites, weather satellites, a whole series. In fact, one of my most favorite memories is a mission that we have a picture of coming very shortly of a Delta IV launch of the Orion spacecraft. Now, if you go a little bit further on, there we go. The Delta IV Heavy rocket you see there on the left has two big stages, 3 boosters across, and on the right, you can see the Orion launch. Now, Orion, for those folks that are familiar with the space program, we're going back to the moon, and the spacecraft that's going to take us there is an Orion capsule, but it's going to fly on a NASA rocket called the Space Launch System. Well, it still hasn't been out to the pad. We hope to get a rollout by the end of the year, but we need to test that capsule. Well, this is 7 years ago. Have the capsule, or a test model of it, would it work? Well, they contracted out to the Delta IV team to put that spacecraft up, send it a few thousand miles away from Earth, use our second stage engine to push it back into the atmosphere so that it would heat up that heat shield to about 4,000 degrees, coming back at 20,000 miles an hour. That would simulate what it's like to come back from the moon. So we can do a moon flight without actually having to go to the moon flight. And that was one of the most tense missions to work on that, knowing that you're really talking about the future. I didn't expect it to be 7 years, but that test occurred 7 years ago. And for the listeners out there, if you want to see that Orion spacecraft, you come right out to the visitor center. It's in an area called NASA Now. The spacecraft that you see there on the screen, right there being launched on December 5th of 2014.
And It is a flown capsule, guys.
It is a flown capsule.
And is it basically identical to in size and everything to the one that's going to the moon?
Right, and that was one of the biggest concerns was the heat shield. If you take a look in that Journey to Mars exhibit, we have an example of how big a Mercury spacecraft heat shield is, Gemini, Apollo. When you see how big that Orion spacecraft heat shield is, it's a lot more complicated. The bigger it is, the more complicated it is. Will that survive re-entry?
Right.
And so that was one of the major parts to look at that mission. And that's why that was so critical.
Hopefully that will be soon.
Hopefully very soon.
Okay, now we have made it sort of, I guess, to the end of your space worker career. I want to mention, I'm going to blow your head up a little bit. I'm going to talk about some of the awards you've received, and I'm going to let you just talk about those. You received 9 NASA Group Achievement Awards, 19 Program Commendations, 13 McDonnell Douglas Boeing Awards, and the Silver Snoopy Award for Safety. Which one of those? I'm assuming the Silver Snoopy is the biggest deal to you.
Yeah, the Silver Snoopy Award. In fact, at the Saturn V Center, we actually have a display on the Silver Snoopy. For those that are not familiar with it, it occurred after the Apollo fire. After the Apollo fire, they wanted some type of special safety award. They did a survey on what's the most recognizable cartoon character, and at the time, oddly enough, was Smokey the Bear. And NASA said that's not a good idea after the Apollo fire to have Smokey the Bear. What's number 2? And that turned out to be Snoopy. And they contacted Charles Schultz, which he agreed to. And starting with Apollo 10, we started having what they call the Silver Snoopy Award. And that was for making some type of great contribution to flight safety. And they limit it to 1% of the workforce. It's like almost like a lifetime achievement award. And it's presented by the astronaut office. It's only presented by the astronauts, and they make quite the fuss. They'll not tell you about getting it. You'll go to a meeting, you'll be as surprised as anybody can be, but they'll invite your friends, family, whoever that they think you'd want to have there. So it's quite a big deal. The program awards, whether it's the NASA Achievement Awards, when we have a mission that had to do a lot of specific unusual things, they would notice that group did a lot of special work, and they'll give it to you and all the members of your team. Think of it as this way: there's a most valuable player during a World Series, but everybody gets the ring because everybody contributed. Think of the Group Achievement Award as like the World Series ring. You're not the most valuable player, but you were on the team, you made a great contribution, you get a World Series ring too.
Okay, now I want to go back a little bit because I forgot to mention a couple of things. One is the picture that we just had a moment ago, the Endeavor. Mm-hmm. Talk a little bit about that, and then I want to go to the console picture.
Okay. People always ask, do I have a lot of pictures of me at work? And the answer is no. I'm doing my job. Don't have pictures. I was astounded one day when I looked and we have the official NASA picture of the first launch of Endeavor. This is a shuttle mission STS-49. If you remember, after the loss of Challenger, we got a lot of spare stuff together and put together this new shuttle called Endeavor. Its first mission was to rescue the Intelsat satellite. So this is the official launch picture. Right there in the front, the big guy in front, I'm sure you'll recognize, is Mike Lineback. Mm-hmm. He was the shuttle launch director. The arrow points to me on the C1 console, which is the first row console. So that is one of the few official NASA photographs. The mission's favorite photo is probably the one next to it. The most unusual EVA. 3 astronauts outside. We had a problem, and right then and there they decided, get a 3rd astronaut. Let's plan that, get a 3rd astronaut to do this. And so it turned out to be a great mission. In fact, one of the people on this flight is somebody we work with, Bruce Melnick. And that was his flight as well. So this was a great opportunity to be in the very first mission of the Endeavor series of flights.
Okay, and then one other photo I want to bring up is the one of the console.
Oh, that's the last photo, yeah.
Yep, the last one. And I want to give my apologies to Miss Jessica, our technical director over there. That's okay. All right, tell us now, is this where you actually did a countdown?
Now, this photo that you're seeing right now, This is at Hangar AE. There's two places we did the launches from. This is for a Delta II mission. There's no more Delta IIs flying. Their last flight was in 2018. I do the Delta IVs from what's called the Delta Operations Center. Now, for the Delta II, people say, wow, it must be easy to do these countdowns and plus counts. I didn't do any countdowns for Delta II, but I did the plus count. After the rocket launches, what is it doing as it's going up? Keep you informed on that. And that gives you an idea of what my displays look like. What am I looking at? And I choose all the different things I can look at. In fact, if you look to the far left, at the far left top is our closed circuit camera on the pad. The one right under that is a cartoon figure of it, because we cannot always see the rocket or the afterwards. So the idea is to see what the rocket is actually doing. So on those displays, I think of what is critical for the mission. I need to know if the vehicle is operating at full power. I need to know the electrical system is working well. I need to know if the satellite separated from the rocket. So I come up with everything that I think is critical to know. There's maps there to show the orbit trace, so I know where the spacecraft is. I need to know where all the ground stations are. When do we expect to get a signal? So I know we're 3 minutes until this station has contact and 4 minutes until it's going to have a loss of contact. To keep all those things in your head while you're doing the broadcast.
So I would just like to add that means that Steve was the #1 man in the Launch Control Center. That's just from Bart. Okay. Now, one of the Atlas and the Delta Launch Control Centers, one has windows, one doesn't.
Right.
Which is
Okay,
which?
Delta has a beautiful view of the pad, and we're closer to it. Atlas has this huge set of monitors that make this, it's almost like an IMAX theater,
Right.
but it's enclosed. But, very, very high-tech situation there. And, in each of the centers, each of them have, their strong points and the weak points. Doing the launch from there, I could look down, you felt like you were watching a baseball game. Below me is all the different consoles, everybody doing those countdowns, actions. And so to be able to listen in on all of that as needed and find out what's going on with the launch. On the Delta side, I could actually look at the pad and see the rocket on the pad and launch.
So you like that one better?
Well, I'm just more used to it. How about that?
Okay.
Okay.
All right. 2016, you retired.
Yes.
And that was a long, painstaking process, no?
Yeah, no, that was very, very difficult. The most difficult thing is when you do your, what they call out processing, is the worst thing is you take that badge off. Well, now you can't go to work. That's awful. So you're always supposed to have what they call the plan B. I know there's some people looking forward to that last day. I'm going to go home and I'm going to start fishing and I don't have to worry about work anymore. I'm not that guy. So plan B was, how do I stay in touch with these folks? And the idea is, well, my very, very first job out there was 1973, and I worked at the Kennedy Space Center Visitor Complex.
Oh.
And for 2 years, from 1973 to 1974, in what they call the Christmas rush, Easter rush, and summertime. And I got to dress up in an astronaut suit and drive a lunar rover. So this is a cute thing. I did get hired very quickly. I was out of work for 12 days. So
12
I
whole
said
days.
12 days between the time I left ULA and the time I started at the Kennedy Space Center again. And let you know, as I was driving to work that day, what should I do to get myself ready to go? I thought, well, the first thing I did was work here, and now I'm back again. I played the soundtrack from Welcome Back, Kotter. Welcome back. And that's it, from the same old place it just started from, and there you go.
Well, and that brings us to how you and I met, because you're a communicator, I'm a communicator, and I try to explain that to people. Yes, we communicate. Yes, we are tour guides. Yes, we are historians. We're the storytellers there. And I believe that we are the small group of people that are responsible for preserving the history of the space program in that particular center. But there are other things. We're going to get away from space for a moment. I want to talk about some of the other things that you've added to your life. I mentioned that you're what's the term? The character?
Right. Yeah, it's called Living History. And the presentations I've done so far, and I've been very, very happy with them. One is on Francis Scott Key and the Star Spangled Banner, and the other is on John Hancock and the signing of the Declaration of Independence. What you do is you get dressed up in the period outfits, and you actually are that person for the next hour or so. And I tell you, when you do that, the one we did most recently of John Hancock, I wrote away to the National Archives, and they paid to get a full-size Declaration of Independence, and we have matching parchment where the signatures are covered up. And the talk is supposed to be on July 1st, 1776. It's going to be presented for a vote the next morning. At that time, the American people, about 1/3 were in favor of independence, 1/3 were against it, 1/3 were on the fence. And so John Hancock is trying to convince the folks in the local audience that this is a good idea, and this is why. And at the end, you get the opportunity to come up and sign the Declaration of Independence. And these folks framed that copy with their signatures on the Declaration of Independence.
Cool.
So that was very, very dramatic.
Now, I have seen his presentation where he is Francis Scott Key, and it is fascinating. And at the end, Francis Scott Key asked the audience if they have any questions. And one of the questions that he was asked when I was there was, how do you remember these things? And his answer was very simple. He said, because I'm Francis Scott Key. I mean, he was totally in character, and it is amazing to see. Now, I'm going to bring something up here. I told Steve that we're going to talk about these things, but there's one thing that I would like to talk about, and I'm not going to tell you what it is. And it's the only thing that I have ever said to him that seemed to make him nervous. And so I'm proud of that. But Steve gave me something about 2 years ago that is a prized possession of mine, and I want him to talk about this. Okay, there we go. Now, I'm going to hold this up. I can get the easel. All righty. This is something Steve gave me, and there's a story behind this.
Okay.
I mean, and it's a great story.
All right. This is 1986, and at this point, we just lost the Space Shuttle Challenger, and everybody has a different emotion. At this time, I am still working for the RCA company. One of my coworkers, Bob Sanker, just came back from Space Shuttle Mission 61C. He landed at the end of, or should say, the middle part of January. That was Shuttle Mission 24. The last flight of Challenger was Shuttle Mission 25. So he was just getting back, and we lost the crew. Now, of course, at this point, I was working, we were transmitting the information, all the way across the United States, getting this information. And one of the ways I've always expressed myself is in poetry. So I decided to write a poem and take an uplifting picture of the space shuttle going into space. It's a 7-verse poem. It takes about 73 seconds to read, about the same time as the Challenger flight. One verse in particular for every one of the astronauts. And the better you know the crew, the better you know who the verses were for. Mm-hmm. And that's pretty much about it. I decided, what do I do with this thing? So I decided it is printed on paper that is what we call index card paper or cardstock paper. And the company that printed them up charged me 1 penny per copy. And we sent them to the National Air and Space Museum in Washington, D.C., where they sold them and kept the proceeds for programs at the National Air and Space Museum having to do with the space shuttle. So the idea was nobody was going to make money off this, and we were going to send everything out. If you remember, about the same time, John Denver made his tribute to Challenger. So I had the poem, and John Denver had the song.
And I want to say again, this is a treasure of mine that Steve gave me. And you have to know Steve to understand that there were 7 astronauts on there, and so there are 7 verses. Each one is about an astronaut. And the rocket scientist side of Steve made it where that when you read it, it lasts the same length of time as the Challenger flight, now, which is sort of amazing to me.
Well, one of my most treasured items is in my on my wall, and it came from June Scobie, who was the wife of the Challenger commander, saying how much the poem meant to her.
Oh.
And that is on my wall at home. So
That's awesome.
in case you're wondering, the first 7 copies of the poem went to the Challenger families. Copy number 8 went to the astronaut office at Johnson Space Center. Copy number 9 went to Bob Sanker, my coworker who flew on the mission before. And I have copy number 10 on my wall.
That's awesome. And I have a copy.
Way
So,
down there, yeah.
I'm a privileged person. Thank you, Steve. I told you it would be painless.
Well, that's good.
Will you read it?
Now? Yeah, sure. All righty. All righty. They were called to the skies. They were called on that day. They flew into the heavens and were there asked to stay. The blinding flash and a thunderclap, our hearts and souls were torn. Your eternal voyage had just begun, and a legend had been born. You were sent into the noonday sky with a mission to fulfill. Your lessons were to teach us much. Now you teach us still. For we will all remember the last words on your ride, full power. It was how you lived. Full power, how you died. The time will come again for us to challenge the morning sky. Your spirit will be with us then, to guide us as we fly. For Challenger, she still flies on with the souls of her last crew. The meek inherit this ancient earth. The stars belong to you. Forever we will seek the stars. Your epitaph is plain. The Challenger and her crew are gone, but their challenges remain.
That's awesome. Thank you, Steve. Well, we are going to wrap this up. I want to remind folks that I am Bart Martindale, and my guest Steve Agid is here thanks to the American Space Museum. And we're going to wrap up this oral histories program, again, made possible by a grant from Marie Louise G. West Endowment. And I'm going to ask Steve to do something that is equally as special to me. And that is, he's told me a story one time of how he got from his childhood to this point in his life. And I think we can wrap up with that story. Would you mind telling us the John Glenn story?
Okay, I will. People ask me all the time, any special memories? Of course, every crew you work with, there's memories on every flight. 2 stand up. One I call a professional memory and one an emotional memory. The professional memory, of course, is working with the Hubble Space Telescope, fixing Hubble. That's going to be hard to beat. The emotional memory, you have to go back to childhood. Goes back, and I'll do the story just like I tell people for inspirational talks. February 20th, 1962. It could have been like any other February morning in Public School 156 in Laurelton, Queens, New York. We went down to the school auditorium, and that was unusual, for today was Tuesday, and Assembly Day is always Friday. Well, we took our seats in the center section of the auditorium and looked to the stage in amazement, because there we saw 2 teachers pushing a cart. On top of the cart was a television set. None of us had ever seen a television set in a school before. Well, sensing the commotion, our teacher, Mrs. Lieberman, came over to us, bent down slightly and whispered, "Shh, you must all be quiet now. A brave man named John Glenn is about to enter a rocket in Friendship 7. He's going to try to go into space and around the world." Well, after the successful launch, we returned to the classroom, and Mrs. Lieberman asked me to stand up in front of the class and talk to them about the flight of John Glenn, rockets, NASA, astronauts, the moon, anything that came to mind, because, well, she knew how interested I was in each of those topics. And that was my first public speech about space. I remember telling the class that the astronauts all worked together, and that the night before launch, astronaut Scott Carpenter went to check out Friendship 7 as the backup and help set some of its switches into their launch positions. Well, I would not have believed it then. I have a tough time believing it now, but 36 and a half years later, under a warm October sky in 1998, I was scheduled to go on board the Space Shuttle Discovery. It would be my job that evening, before launch, to set some of Discovery's switches into their launch positions before the very next flight of astronaut John Glenn.
It's an amazing story. I want to end with that. I want to thank all of our viewers on Facebook, YouTube, Twitch, for watching today. And I want to thank Steve for helping me bridge the space between all of us. Thank you, Steve.
Well, thank you so much,
been my
Bart.
pleasure.
It's been fun.